And so it goes to the Environmental Protection Agency, which on December 7th, 2009 issued something called an endangerment finding, and according to the Supreme Court, they therefore must regulate it. Let's read their endangerment finding, the guts of the endangerment finding. Most of the observed increase in global average temperature since the mid-20th century is very likely due to the observed increase in anthropogenic greenhouse gas emissions. Thank you, EPA. You just gave me, see, the problem is our greener friends give us what we call testable hypotheses, all right? What does the word most mean? It means more than half, right? Mid-20th century means since 1950, right? And according to the United Nations, very likely means between a 90 and 95% probability. So most of the warming since 1950 was a result of greenhouse gas emissions. Now, let me tell you something. I'm about to show you the temperature history from the Climate Research Unit at the University of East Anglia. If you know the ClimateGate issue, this is the epicenter of ClimateGate. But let's say that it's right. Let's just say that it's perfectly fine. We'll start tearing it apart in a minute. Here's the warming since 1950 in that temperature record. And you can see it goes up. There's a linear trend in temperature of about 0.7 degrees Celsius. Fine. So what the EPA just said is most of that warming is a result of changes in greenhouse gas concentrations. Well, it turns out that one of the guys in the Climate Research Unit was the junior author on a paper that appeared in Nature magazine a couple of years ago, in which they found that these temperatures here over the sea surface from 1945 to 1965 were measured too cold. And so they have to adjust the temperature record for the fact that the early years are too cold. And here's what you get if you do that. The warming drops from 0.7 to 0.55 degrees. Fine. So you've lost a little bit of the warming. My friend Ross McKittrick and I from Canada published a bunch of papers on what we call non-climatic influences on the temperature. Urbanization, the fact that forests get mowed down and turn into cornfields, etc. And we found that about half the land warming, land's only 30% of the Earth, you can't get this effect over the remaining 70%, might be due to those effects. And when you subtract all that out, you don't lose that much. You lose about another 0.08 of a degree. So you're down to 0.47 degrees. But that's completely independent of the fact that the ocean temperatures were measured wrong. And by the way, just a little home news here. These are warming trends in California. See? This is Jim Goodrich's work from a few years back, but it's still good. This is the warming trend if your county population is greater than 1 million. This is if it's from 100,000 to 1 million, and this is less than 100,000. That's odd. So the greater the population, the greater the warming. Obviously, there's some effect here that isn't climatic. And this is effect of population on the temperature history. This is the warming trend in degrees per year. Here are all the northeastern states: Delaware, Maryland, Connecticut, Massachusetts, Rhode Island, and New Jersey. The more dense the population, the more it warms. I'm really shocked. It's called the urban heat island effect. Bricks the buildings, the pavement, they retain heat. They don't allow the wind to flow through at night. In Washington, we have the additional effect from waste heat from all the money changing hands and bodies bumping into each other in unusual combinations of age and sex. Anyway, and down here we have Maine. Well, there's hardly any people that live in Maine, but Maine happens to be right next to, I heard, Massachusetts and Rhode Island, and it has a cooling trend. So you tell me. You can see there are problems with this temperature record. Then, here's the difference in temperature, by the way, temperature trend from 1900 to now. Here's Rhode Island, second densest population in the United States, and there's Maine, one of the lowest population densities. You think the climate changes so much across 100 miles? No, it does not. There are problems with these temperature records. Anyway, then Susan Solomon from NOAA, National Oceanic and Atmospheric Administration, published a paper in Science magazine early in 2010, in which she says, okay, we admit it. You've heard this on afternoon talk radio, which is morning talk radio out here, that there hasn't been any warming since 1998. It's true. And what I call the mainline government scientists, I was state climatologist in Virginia for 28 years, I call them federal climatologists. The state climatologists have a bit more independence than the federal ones. It may shock you. Anyway, having something to do with the ambivalent relationship between Virginia and the federal government over time. That's a joke. Anyway, so what Susan Solomon does And she says, okay, here's why it's not warming up. It's because water vapor is changing in the stratosphere. She's a stratospheric chemist. And, okay, fine, Susan. And so that adjusts the warming trend down. Whoa, sorry, I went the wrong way. There we go. That adjusts the warming trend down another 1/10 of a degree or so. Now, hey, I'm Al Gore, okay? I'm just like you, only better. You know, I put my hands like this, I'm lying. Well, Al Gore says the science is settled. Susan Solomon, who is a pretty active activist on this issue, introduces an entirely new variable into the climate change modeling world called stratospheric water vapor. It wasn't in there until January of 2010, and she loses about 15% of the warming. The science is not settled. Anyway, finally there's a guy at Stanford by the name of Ramanathan, and all these people will go on television and tell you you have to do something about global warming. Ramanathan studies black dust in the atmosphere, soot that goes in the atmosphere along with everything else that we burn, but it's not a greenhouse gas. And he thinks that's responsible for about 25% of the warming trend. So we add all these things up, and we got 3/10 of a degree remaining out of the original 7/10. That's less than half. None of these things are greenhouse gases. The sea surface temperature was measured wrong. There's a land use effect on the temperature. Stratospheric water vapor is increasing, and there's black stuff going in the atmosphere. Not only are those not greenhouse effects, but they're all independent of each other. And so you can add them up. The EPA is going to see this argument in court in the not too distant future. Okay, so how urgent is all this stuff? Well, this is the IPCC. Each one of these pieces of colored spaghetti is a climate model from the United Nations Intergovernmental Panel on Climate Change, of which I am a member, by the way, proving that all garden parties need a skunk. However, the skunks are popular speakers as long as you don't get close to them, so the skunks tend to fly in front of the airplane. Anyway, I know you all think that too. Each piece of colored spaghetti is a computer model, and the black line is the average of them. I'd like to point something out. Our computer models tell us, in general, for what we call the mid-range emissions scenario, that once global warming starts from human influence on the atmosphere, it takes place at a constant rate. Fine. So, that means that if the rate of warming in fact is constant, even if this temperature record is screwed up, you should be able to figure out what the rate of warming for the future will be. How hard is that? Well, it's like when you teach weather forecasting. Computer model says it's going to rain tomorrow, another one says it's not. What do you tell students in weather forecasting class? I've taught this several times. Honest to God, look out the window, Jack. Okay? Which model is performing very well? Well, okay, look out the climate window, Jack. There you are. And there's the climate. That's believing the temperature record that we have. And what you see is a warming of about 1.5 degrees over the course of 100 years. Not the 3 degrees that we hear about. And you know what? Seeing as you've had 0.8 of a degree of warming since 1900, I suspect you're going to live. I might be wrong about that, but I do believe that life expectancy has doubled since 1900 in the industrialized world, and corn yields have quintupled, and wheat yields have doubled, and Paul Ehrlich was really, really wrong. But he still flies in the front of the plane. Anyway, grumpy, grumpy, grumpy. So, why is the warming rate so low? Well, because the science is settled, obviously. Now, here's what's going on. Okay, let's go forward. There we go. The main driver, greenhouse gas driver in all these models is carbon dioxide. And this is the range of carbon dioxide concentrations projected by the Intergovernmental Panel on Climate Change. And the red line is the observed value. Where are we? We're at the bottom of the range. So it shouldn't surprise you that the warming's at the bottom of the range. The second most important greenhouse gas we put in the atmosphere is methane. It's got the following major sources in descending order. Bovine flatulence. Drive up Highway 99 from Anaheim, as I did yesterday, and I can assure you that there are not less bovines in California in the world. And people happen to like beef, particularly people outside of the United States who haven't had very much of it. Then there's rice paddy agriculture. The last I heard, people eat more grain. And yes, crop yields continue to increase at the rate that they have been increasing for the last 50 or 60 years. Coal mining and leaky pipes are other sources of this. Well, anyway, so I'm a scientist in 1990 when the Intergovernmental Panel on Climate Change decides to first start meddling in political science. All of us think that methane is going up in the atmosphere and it's going to continue to go up at the rate that it's going to go up. So the consensus of scientists is the second most important greenhouse gas is going to go up in the atmosphere. And here is the projected range of methane concentration in the atmosphere, and there's the observed value. You see, every scientist in the world, including myself, would have just extended this line pretty much up. But in fact, it had started to go down, the rate of increase had started to drop in the early 1990s as soon as we said it would increase at the rate it was increasing, and in certain years, since this year 2000, it's actually gone negative in the atmosphere. So that's your, the main greenhouse gas, CO2, is at the low end of the projection range. The second most important one, methane, is beneath it. Are you shocked that warming is underneath what it's supposed to be? This is a big embarrassment, but who is going to come out and talk about it in public except idiots like me? Okay? And then there are other aspects of urgency. This is the Arctic ice. Satellites began measuring in 1979, and its departure from normal in millions of square miles. And you can see this is in mid-August. It was about 1.2 million square miles below its average from 1979 to 2008. You see graphs like this all the time. Well, one time there was a picture of the Earth in a newspaper, and the southern hemisphere was on top of the picture. And Al Gore said, "Oh, you've got the Earth upside down." Not really. You can look at it the other way around. The southern hemisphere is on top. It has nothing to do with being upside down. And there's ice in the southern hemisphere too. The satellite goes around and around in polar orbit. And once it gets out of the northern hemisphere ice, it goes down around and measures the southern hemisphere ice. There you go. Plus 1.54 million. And in fact, there's a statistically significant increase in southern hemisphere ice. It's well known, except in the Intergovernmental Panel on Climate Change reports, which say that it doesn't exist. Unfortunately, the satellite tells us that there's a less than a 1 in 10,000 chance that it's not increasing. Okay, now I'm going to close this talk with BS. Okay, there's a lot of that on this issue. And what happens if you gave the argument that I just gave, and you were at a cocktail hour? Here's your greener friend. This is a ranch dressing soaked carrot stick. They're poking you into a corner and saying, well, you don't care. All the ice could fall off of Greenland. The sea level could rise 23 feet in the next 100 years. Yeah, one guy says this, James Hansen from NASA. Scientific literature does not say this. Even the United Nations says the median rise is 13 inches in the 21st century, and it appears that it's running at the low end of that, which is not exactly something that's going to kill you. Anyway, so that Greenland scenario is that ice down from Greenland is enhanced by meltwater. So 2 inches of sea level rise from Greenland in 2100, we get 20 feet. And is warming there going to be unprecedented? Good question.